First of all, I'd like to thank David and Nico for organizing this. This is new, and a lot of people have been working pretty hard behind the scenes to put all this together. It's certainly not trivial, so that's fantastic. We'll see how that goes. And a big thank you to Lenaro, who's hosting our Zoom channel today. When we started discussing doing this dev day a while back, we were trying to guess at how many participants we would have. And we said, oh, probably 100 or so. And we've been overwhelmed by the response. So it's been quite fantastic. Like David said, we will have a hands-on portion later. I'm going to talk for a little bit first. The environments have been set up. According to Michael, they're all synced and ready to go. But I'm going to talk for a little bit before we do the hands-on. So there'll be a bit of talking. We'll do the lab in the middle, and then we will have a little bit more talking at the end instead of just having all lab or lab only at the end or something like that. It's a 90-minute slot, so we have lots of time. If you do have any questions, there's the Slack channel. And if you are watching this, sometime in the future, there's the IRC channels on Freenode. If you go to #Yocto or #OE and ask questions there, my handle is TL Woerner, but many of the people who hang out in those channels will be more than able to help with these sorts of questions, these labs and whatnot. And all the material will be posted online, or is posted online now, or will be available later. So that's great. All right. So about 18-ish or 19-ish years ago, I was working at a company and they put a device on my desk and they said, we need Linux running on this. And I was the only Linux developer there. And it was a very embedded device. It didn't have a lot of disk space type thing. It didn't have much of a powerful processor. And it needed to be cross-compiled and all that sort of stuff. And back then there certainly wasn't the Yocto project. And there wasn't much actually in the way. It was a lot of work to get that stuff working. And when I meet other people who have used the Yocto project, what I find interesting is they fall into two broad categories. Either they say, oh, this Yocto thing is crazy. I mean, it's horribly over-engineered. It's way too complicated. And then there's the other people who say, wow, this is fantastic. Where was this, 2 years ago when I needed this? This has simplified my life incredibly. And the reason why you have that divide, I think, is the people who find Yocto an easy thing, something that's helping them and very intuitive, are the people who have probably had to do this by hand and gone through the pain of all the little things that you need to do and know in order to put together an image and all that stuff. Whereas the people who maybe might not have as much experience cross-compiling and that sort of stuff, or having to configure a kernel or BusyBox or something, I think they're surprised by how complicated this can get. And so before we launch into sort of the meat and potatoes of the talk, I wanted to sort of take a little trip down memory lane and sort of discuss, what is the Yocto project trying to do? How is it trying to help you? And I don't think you can understand how it's trying to help you if you don't understand what's involved with doing this by hand type thing. So if you had a device and you're trying to get a kernel on it, you would have to get your kernel, you'd have to obtain it, you would have to cross-compile it and get a tool chain, set up the tool chain, configure the kernel, and then you'd have to build it and then installing it, et cetera, et cetera. And I'm a big believer in getting sort of the minimum stuff working first. So you would want to see your kernel booting. Maybe you can't come up to a command line quite yet, but at least getting the kernel booting. And then afterwards, you would then want to do your job, which might be to edit the kernel in some way or to write a module or enable the RT preempt stuff. So, but first you would want to, sort of get the minimum. So getting a kernel, what kernel do you want? What kernel do you have a choice? Is there a vendor kernel that you have to use? You might want to use an upstream kernel from kernel.org, or you might want to use an LTS, a stable kernel type thing, like the ones that Greg KH releases and stuff like that. And I want to draw a distinction between vendor kernels and evil vendor kernels. Sometimes you can't use an upstream kernel because the stuff just isn't in the upstream yet. And it's not for lack of trying. Getting patches into the kernel doesn't happen easily. Sometimes it can take a while for these things to get upstreamed and whatnot. And so there are vendors who are trying very hard to get their stuff upstream, but it's not quite upstream yet. And so you have to use um, their kernels. And then there are other vendors who forked off somewhere in the 3 era, and there's no chance of their stuff ever going upstream or being upstreamed. And so, um, you know, you're stuck with a Franken kernel that has just hundreds or thousands of patches applied. But sometimes you have to use these if your board is relatively new. So where are you going to get your tool chain from? More and more nowadays, distros are coming with cross compilers, so that makes it easier. You just simply install whatever your distro provides. You could also get the sources and compile your own. Good luck with that. That's not something that's going to be trivial. You have to start off by creating a like a proto compiler, and then you have to use that quasi compiler to compile a little bit of whatever C library you want to use, and then you have to include the headers for the kernel that you want to use into that. And then that allows you, now you can build the full cross compiler. And now that you have a full cross compiler, you can now build your full cross C library. And then, so it's quite a jig. And the options that you pass at the different phases are very, you have to pass specific options. It's not just random things that you're passing and setting up. It's quite a song and dance to get that working. If you're still intent on compiling your own, you could use a tool like CrossToolNG, for example, which provides a kconfig style environment that allows you to pick and choose, and it helps you to create a cross compiler. Doesn't always work because not everything always does work. Or you could get a binary toolchain from the ARM Linaro folks, or you could go to Bootlin's site. They have a pretty nifty site for getting tool chains, binary tool chains. Arnd Bergman from Linaro actually has a place on kernel.org where he creates and uploads tool chains, binary tool chains. But note that those tool chains don't have, you can't compile user space with it. They're only for like the kernel or U-boot and stuff like that. And then sometimes if it's a really esoteric SOC, then you have to use a vendor tool chain. For example, if you want to download the Linaro one, you would go to Linaro or ARM site, and this is kind of where you would end up. This is what the interface looks like for downloading toolchains from Bootlin. You can select your platform, you can select your C library, and then you can either download the stable or the bleeding edge. It's pretty nifty. Here is, this is just a screen capture, kind of the top portion of the website at kernel.org that Arn put together. There's many more, like they start back at 4.7 or something like that. And there's like every platform that the Linux kernel has ever targeted. So there's, a couple dozen of them. Yeah, and once you have now your toolchain set up, you have to set environment variables or simply specify them on the command line every time you use your toolchain. It's a little different. Cross compiling is a little different than just compiling for your host computer. Then to build isn't too difficult as long as you've got everything in place. And then, but installing, now that's the tricky part, because by default, the kernel will want to install itself on the host computer. It kind of assumes you want to do host stuff. And But when you're using an embedded device, there are lots of variations. I mean, sometimes you need to put the kernel in its own partition. Sometimes the kernel is in the file system image. Sometimes, depending on whether you're using flash, whether it be NAND or NOR flash, there's just, sometimes you need partitions, a fat partition at the start, and that's where you put your kernel. And it's really tricky to get the install part right. It's very complicated, and there's all sorts of different ways. ext, you might be using a fit image, or you might, or where you put the device tree blob, the device tree binary, can be different. Sometimes you append it to the end of your kernel. Sometimes it needs to be in its own place, its own partition, or and how your bootloader finds it and stuff. I mean, these are very, every board is unique, unfortunately. It's not just sort of like a desktop environment. So there's a lot to need to do and know. To make it even more crazy, sometimes you don't even create partitions. Sometimes you'll have like a hard drive, and your first partition will start, way off, several hundreds and tens of hundreds kilobytes into the drive, and you just simply put your kernel in some magic place that isn't even, it's just a, at offset 2002K, here's where your kernel starts type thing. And then, if you're using raw flash, then you might want to use JFFS2 or UBI. And the initial, the two partition dance that some of them need. So the point is, there's a very tight coupling between your bootloader, your command line, how you get the command line to the kernel, where you install the kernel, the modules. The modules go in the file system, of course, and then the device tree, and assembling all that and getting that all right. It's a lot of work. If you then wanted to edit the kernel, that's not too complicated. Just make sure you're editing the right place. But it does become more and more complicated if you have multiple boards, multiple configurations to have to manage, especially if the boards use different architectures. And you have to make sure, of course, you're using the right tool chain. Writing a kernel module by hand isn't too hard. There is, you do have to just search for it online, and there's like a template makefile you need to use. So it's not too complicated, but not as simple as host stuff. And then, of course, at some point, you're going to want to play with the preempt RT. This is embedded. Everyone wants to do preempt RT stuff. And I just hope that if you want to do RT stuff, that the kernel version that you've chosen is one for which the RT patch is available, because trying to patch in an RT patch for a kernel that's not aligned with it is quite challenging. It's getting easier, actually. The RT patch is getting smaller, but yeah, it's not trivial. So if you are not using Yocto, doing it the first time will be quite tricky. Once you've done it once or twice, it's not as hard, but if you do have multiple devices, then it becomes quite complicated to keep track of everything, keep everything all in the right place. So can the Yocto project help? Yes, of course it can. Helps quite a bit.
Excuse me, Trevor, can you move your microphone a little bit closer to your mouth? A couple of people like you a little bit louder.
Okay, I'll have to speak louder because it's just simply a
Okay.
microphone out of my laptop.
With enthusiasm.
Yes, okay.
Thank you.
So first of all, I'd like to identify two different types of users. There are people who are working with an already established board, an off-the-shelf type board, maybe a Beagle or a Pi or something. And there's already an existing BSP layer for that on layers.openembedded.org. And then there are other people who have a unique board. Maybe their hardware department has taken a reference board and tweaked it a little bit, and it's a newish board. and they need to create a BSP for it. It's a board bring up type scenario. Um, so uh, if you are using an existing BSP, then everything that I just talked about for the last 15 minutes has been done for you. It's, unless you're selling people a device, unless you're saying, here's a device and it runs the 4.7 kernel, that's what you wanted, right? Chances are people aren't buying something because it has a kernel on it. They're buying it because it has your special sauce, it has your app, it does your thing. Um, and so if you have a board that has a BSP layer, then all this is done for you. You can get on with your job of making that special stuff instead of worrying about this. And that's fantastic. That's a lot of work that's already taken care of for you. But even if you are using an existing board, chances are you might want to say, try a different kernel or change the kernel somewhat. You might want to tweak the configuration. You might want to enable something that isn't enabled in the base BSP def config. You might want to edit the sources somewhat, or you might want to write a kernel module for it. But even if you want to do all those things, you still don't have to worry about building and the cross tool chain and setting up a cross tool chain, or figuring out how to lay out where the kernel goes or the modules or the device tree. All that's done for you. You can focus on your thing, and that is fantastic. So if you want to change the kernel, there are many kernels to choose from. You can use upstreams or vendor kernels, stuff like that. But the Yocto project provides its own Linux Yocto. And I want to make a huge shout out to Bruce Ashfield. He's the person who primarily does a lot of the work of creating and maintaining Linux Yocto and all the tooling and stuff that goes around it. And it's just a phenomenal amount of work. And I think it works amazingly well. I mean, obviously, when you're following the bleeding edge all the time, there can be snafus, but it's just a huge amount of work. A real shout out to him. It's fantastic. And not only does the Linux Yocto, not only is there like the Linux Yocto, it also comes in variants. It comes in a tiny version or an RT version. If you want to try, you just simply do a preferred provider virtual kernel for the RT, and now you're playing with the preempt RT kernel. It's pretty nice. And then the dev variant is a variant that is like it's more of a bleeding edge, whereas the base one will tend to be the stable version. Than the dev, if you want to try something a little newer, that's what the dev is for. But not only does he provide this Linux Yocto kernel, but it's been provided in such a way that even if you want to use your own kernel sources or something like that, if you don't want to use the actual Linux Yocto, when you write your kernel recipe, you can just simply include or require 2 components, and you have now all of that amazing tooling available for your kernel variant, which is just quite, it's been done quite well. It's quite interesting stuff. When it comes to tweaking the configuration, the config of the kernel, you can just drop in your own def config. You can use some SOCs, some boards have a def config in the kernel tree. So you can just specify that and say, yeah, I just want to use this def config, and the build can go ahead and do that. Or you can create fragments, which are applied on top of a base configuration. We'll be talking a lot about fragments later. So, and then if you want to edit the kernel code, why you would want to, maybe you just want to do some debugging. You want to just slap in a couple of PR notice, which is sort of the modern print K, to see, what's this value at this point, or why isn't this part working or something. If you want to do quick little changes like that, or if you have a piece of hardware like a USB stick or some PCI device that's very similar to another one, but the PCI IDs haven't been added to the kernel that you're using, it's a very quick way. You can just go in and edit the device table and add your device so that the kernel will recognize it and use it. And then writing a kernel module is a very frequent activity with embedded devices. Chances are your hardware team has created some special thing on your specific board and it needs a module to get it working. And so there's a lot of tooling in the Yocto project to help with that. And then if you need that module to auto load, you just simply specify it in your configuration and it will. And just make sure to include your module in the image itself. The core image minimal won't install modules and stuff, so you just need to do that yourself. But yeah, if you do that, if you follow the rules, then it has a lot of stuff for you. Now, if you're creating your own BSP, if you're doing board bring up, you have to do a lot more work, but there are still things that are taken care of for you if you are using the Yocto project, the tools and stuff. It knows how to obtain cross tool chains and stuff like that, or how to obtain the sources and all that stuff. And it knows how to build all the various components as well, all the C flags and everything else, and putting them in the right order and getting them all set up correctly for your architecture. All that is kind of done for you. So even though you have to do a bit more work than if you were just given a BSP layer that worked for your board, still, I mean, you're not starting at zero. And even with the things that you do have to do, there's a lot of help provided to you to help you do those things. You know, the Yocto Bitbake knows how to fetch code from Git repositories as tarballs. It knows if you need passwords. It knows how to go through proxies and stuff like that. If you need to fetch code, so obtaining the kernel is not, I mean, you just point to it, specify a URL, and it's good to go. Setting up the cross tool chain, you don't have to do all the compiling and set that all up. You basically just have to create a machine file and set the proper tunes in it. You know, hopefully your SOC already has an existing tunes. And once you've done that, the magic happens all on its own. You're not having to do that proto compiler, proto C library stuff. And that's all thanks to the fantastic work of Cam. Cam Raj is the tool chain person. And all that magic, you know, happens because of people like him. So it's fantastic, you know. And then there's lots of tooling around configurations and, like I said, around config fragments and stuff like that. So creating a default config is quite straightforward, quite simple. And then, of course, installing, even though there's no way for Yocto to know the specifics of your board, and like I said, pretty much every board is unique, there's a lot of tooling in the Yocto project. For example, if you are in the situation where your device tree blob needs to be appended to the end of your kernel, then that's like a one-liner in your config file. You say a bundle, there's like a bundle something, Linux bundle, and boom, it knows once it's compiled the kernel that it's going to take the kernel and the device tree that you specify, and it's going to cat them together, and now you've got that all set and ready to go. So although it can't know that you need to bundle, if you know you need to bundle and you specify that option, it does the bundling for you. And there's just dozens of other examples of, you know, if you need a ext Linux file, again, you specify a bunch of configuration parameters and it'll go and generate the file and put it on your file image for you. Under boot by default type thing, which is usually where your bootloader is going to look for it. So all these things, although we can't know the exact mechanism, there are lots of standard mechanisms, and there's lots of tooling that'll help you to get your image done. So you're not starting at zero, even if you're creating your own BSP layers. Okay, so Let's play with a bunch of stuff. I've been yammering on for a while now. Everyone's probably itching to try out some exercises. So I'm going to quickly walk through. Going to quickly walk through what I'd like to see you working on, so that you have at least a little bit of a understanding ahead of time. So I'll be on the channel for a bit, and if people want to stretch their legs or whatever. It's a 90-minute time slot. We've already taken up 30-ish of those minutes. And so what I have left is probably another 30 minutes of talking. So if we wanted to go 15 or 20 minutes, I'll let David decide. But we can probably do the hands-on. We'll break for about 15 minutes or so, 20 minutes, let people work on their hands-on. But for now, I can't see if there are any questions, but if there are any questions, why don't we take questions for a minute if there are any or two? Yeah.
So post your questions in the Slack channel. That'll be the easiest way for us to find your questions. And Trevor, will you be walking through your exercises so people can see you doing the steps?
Yeah, I've got them all in slide format, so I'm going to walk through them in slide format, and to give people a heads up. I'll go ahead and do that now, I guess. I don't see any questions, so we'll go ahead. So this first part we can actually ignore because the environments are already set up with the Pocky repository already set up at Dunfell. When you log into your home account, there should be a soft link to the Scratch. So if you just cd Scratch, you'll find Pocky sitting there. We need hopefully, my guess was that most of the people attending this have probably seen Yocto, maybe tried a basic image before. If not, I mean, there's lots of people that can help guide people through, but hopefully by using the environment, it makes it easier a little bit. So you have to initialize, you have to source the script, the environment script to set up your shell. I like to, whenever I'm working in a modified shell, I always like to tweak my prompt to remind me. I always have dozens of terminals open on my computer, and I like to remind myself that this is a modified terminal. This is the one I'm doing my builds out of. So I always just tweak my PS1, my prompt to just remind me of that. That's an optional thing. I'm probably giving away my age by, I think that was something that was done more traditionally. And then you'll need to tweak your, oops, that's local.conf, not just local, conf local. I would usually hit tab at that point. So anyway, so you'd need to edit conflocal.conf and switch the machine to x86-64 and switch the download directory in the S state. If we all use the same S state, your builds will go a lot faster. And then optionally, you can play with an SDK if you get done quickly. So if you do want to play with an SDK, you'll have to set the SDK machine to a 64 because these machines are 64. And if you set the terminal to screen when we do the menu config stuff, then it'll just work a lot better. So tweak, you can delete all the comments. Anything else that's commented, you can delete. Keep anything else that's commented in, but just make those changes. And then we'll start with, again, I like knowing that it works first before I start tweaking it. So if we do a bitbake core image minimal and that succeeds, then at least we're all at a good starting point. And then we'll need to run the image, and we're going to use QNU. And again, Yocto has some fantastic tooling around using QEMU with your QEMU images. The slurp stuff is so that it doesn't ask you for a password. So the networking stuff. No graphic is so that it won't try and pop open a second window, a graphical window. And then serial allows the console to show up on your command line in situ, basically, where you are. So if you run that, hopefully it boots up and it comes up to a prompt. And we know we're good. So for now, we'll just log in as root, no password. And then if you do a uname, you can see what version you're running. And notice the preempt, SMP preempt. That's something we're going to notice later. So just make a note of that, that right now the default has preempt turn on. And then if you do a shutdown H now, it'll shut down and bring you back to your prompt again. For the work we're going to be using DevTool. And there will be a DevTool talk later by Paul Eggleton, the person who mostly wrote DevTool. So I'm quite excited about that. And but anyway, we'll be using DevTool for this. And so we need to create a layer because when we're done tweaking things, we need a place to put that. And so we need to create our own layer. So we just create a layer and then we add the layer to our build. And yeah, and all we're set to go. So the prep is done and we can now play with stuff. Anyway, so using DevTool, we're going to modify the kernel recipe. So DevTool modify virtual kernel. And the dark stuff is what you type, and the lighter stuff is what you'll see as a result. And if you look at the info stuff, you will see that it's telling you that it's copying the kernel config and the sources are being extracted into your workspace. DevTool will create a workspace for you. You'll notice if you're at your command line, if you do an ls, you'll see that a new directory has appeared, workspace, and that's where you're going to be working from. That's where DevTool does its work. So it's just informing you that it has set everything up in your workspace for you. So that's kind of neat. And then we are going to edit in the workspace the Linux sources. We're going to edit init, the main.c from init, from the kernel's init. And around line 1143, we're just going to add a PR notice. And this is the point right before it's going to start looking for an init routine to run. The kernel's, one of its main jobs is to look for init and run it, and then that's all it. And so we're just going to add a line, and I added it here because when we start up our QEMU, we want to see it without having to scroll back too far. And since init is one of the last things the kernel will do, we'll see it hopefully closer to the end. So anyway, we'll edit that. We'll just put something in, put whatever you want. And then we build. And it tells you, it's saying, by the way, I'm compiling from the workspace area, just to make sure you're, and then so when we start run QEMU again, if you might have to scroll back, but hopefully it'll be sort of there. You'll see the line added somewhere just after it mounts the VFS, and somewhere right before running sbin init.
So Trevor, this is your dry run. People were asking. You're just kind of describing what you're going to do, and then they'll do it after this.
Yes.
Okay,
exactly.
so no worries. You're trying to keep up with Trevor.
Yeah, no.
He's fast, but you don't have to be that fast.
Yes. And then, yeah, we're going to break for like 15, 20 minutes after, within a couple slides, and then you'll be on your own for that. No, I'm just kidding. Yeah. But, so if you're happy with your commit, you've tested it now, you've made a commit, you've tested it. If you're happy with it, you would go into the kernel sources and commit it. And just, write a commit, and there you go. And then here's where the dev tool really shines. For example, if you're happy with all that, you've made your commits, you could make multiple commits, you could rebase your commits, you can git add -p, to reorganize your commits, do all that stuff. Once you're happy with all your commits and stuff, you do a finish. And DevTool is smart enough to know where you started. You started after this commit, and these commits are yours. And it'll take those commits as patches and create all your patches and put them into the layer that you created. And also create a BB append for you that includes those patches, so that they're all set and ready to go. There's your patches, there's your work for your kernel. And when you build using that layer, all your tweaks will be in there. I emphasized it won't show up in red, but I made it red just to emphasize that the very last line after you do a DevTool finish will be to remind you it's going to leave the source tree where it is. And if you're done with it, then you can remove it yourself. There is an option to DevTool finish. I think it might be R-R or something like that. And it will just do that remove for you. But anyway, whatever. You do it this way or the other way. Now, if you look at the My Tweaks, because when you did the DevTool finish, you said DevTool finish what you want to finish. So you're finished with Linux Yocto, and where to put it, which is the meta My Tweaks layer that we created in the sort of the startup. And if you look at My Tweaks now, you'll see that DevTool has created the recipes kernel, Linux. It's copied the layout from where that recipe was found, and it's created that patch, and it's created a BB append for you that includes the file, extra, know where to find the patch and all that sort of stuff, files, extra paths, or whatever it's called. Yeah, so it does all that for you. It's quite sophisticated, quite nifty, but it's there. It's all done for you. And yeah, so that was sort of the first, that was a second thing to do as part of the lab. And now we're going to play with tweaking the kernel configuration. So again, we modify, we tell DevTool, we're going to use DevTool, and we start up the process by telling it we want to modify this recipe. I guess there is a little, I have a tiny beef with this. I don't know if it's an error, or maybe it's just an improvement. Here I've specified virtual kernel because that's what I want to modify. But once DevTool takes it into its workspace, it doesn't know it by the virtual name anymore. It knows it by the actual name, which in our case is Linux Yocto. So you might have noticed that the initial DevTool commands are for the virtual kernel, and then it tells you, I'm now set up to build recipe Linux Yocto type thing. So, and then that's how I know to say Linux Yocto now. But anyway, one of the neat things that DevTool has is to be able to run the menu config. And so you just go DevTool menu config on the kernel, and it does its stuff. And in a second or so, this pops up. And and it's all set up. It's the proper, it's got all those command line things that you need. The environment, the arch is set, the cross compile line is set. It's all set to go. So as you can see here, it's using the Pocky toolchain, which was built as part of your core image minimal. And at the top, it's the x86 architecture, which we're already on an x86 architecture. If this was an ARM target, then you would see Linux, ARM, or AArch64, or MIPS, or whatever. But all this stuff is set up for you. You just simply type DevTool menu config, and you're ready to go. So if you navigate to general setup and then preemption model, and you switch it, by default, it'll be in the preempt RT. And if you just switch it to the first one, which is the no forced preemption, the server. And then you either hit escape twice, a number of times, you kind of double tap escape, tap, 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 and it gets you out, or you can just select exit at the bottom. And then at the end, it will say, you've changed your configuration. Do you want to save? And you say yes. That's all you have to do. And then Yocto kicks in, DevTool kicks in, and does its magic. And it goes and it looks at what your config was and what it is now, and creates basically a diff between that, and saves that as a fragment. And it even says, oh, I've saved this fragment to your workspace, blah, 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 DevTool fragment.config. So now if you build your image again and run it in QEMU, you will notice there's a line as part of RCU. And if you have the preempt kernel enabled, then it'll say preemptible hierarchical RCU implementation. Whereas now it just simply says hierarchical RCU implementation, because you're not running a preempt kernel now. And when you do the uname, you'll notice that the preempt string is missing from your uname-a. So we are running a non-preempt kernel now. We've changed the config, and now when we finish, we do the DevTool finish as before, remove the workspace, and we look at the tree, we can see that in addition to the patch, there's now the fragment and the BB append. As I should have posted the BB append, but basically it'll be pointing to those two things, which is kind of neat. And if we look at the fragment, this is all that it is. This is the only difference between the original config and the previous config. And so, and that's your config fragment. While I was playing with this, I did notice, again, this might be maybe an improvement that could be, maybe it's on my to-do list, I don't know. But if you then do another config fragment, the first one's going to be overridden. So if you were going to do multiple fragments, then you would want at this point to stop and rename the first one and tweak your BB append. It's hard-coded in the DevTool sources to just simply keep using the name devtool-fragment.cfg. But anyway, just something little known. If you're not sold on using DevTool, if DevTool is not your friend, you could use BitBake to create your own SDK. And, maybe you're old school and you prefer doing this sort of stuff by hand. So you could generate an SDK, but even there, Yocto is still trying to help you, because as part of generating the SDK, it will create an environment file for you, and you have to source that environment file before you can use the SDK. And in that environment file, you will find defines for the arch and the cross compile. So you create your SDK, you install it, you source the environment file, and then you could just go to your kernel sources and type make menu config, and it'll already know which arch and where your cross compiler is and all that stuff. So
Excuse me for a second, Trevor.
Yeah.
I just want to say, we actually have several channels in our thing, and there was some confusion about which channel to post to. We had thought that the Dev Day Virtual ELC NA 2020 would be our channel, but it appears most people went to the default channel, which is the Yocto project. So I think since most people are on the Yocto project, let's just all move to the Yocto project, and that way we can have all the questions and history in one place, and we know where to look for your comments and questions. So if you're over on, oh, and that one is gone, the old one. So we moved you over. Thank you so much. Okay, back to you, Trevor, for our regularly scheduled program.
All right, thanks, David. Yeah, I think that's actually it. So let's break for, well, I'll let David decide actually. So I'm gonna break now. I'm gonna go get a drink of water, and I'll be sitting in the Slack channel and give everyone an opportunity to play with those three exercises. Like I said, David, I have about, I don't know, 20 minutes left of talk, and we still have 45 minutes left in our time slot, plus there's a break after this. So I'll leave it up to you to decide when we'll come back.
Yeah, so everyone go ahead and get the slides with the instructions. You can copy paste and start trying out in your session. And we have pre-built the whole project up to the core image minimal, so you can just start after that. And we'll all be hanging on the Slack channels to answer questions, but go ahead and just start using the instructions and see how far you get. And okay, so it'll be about 20 minutes after, so about 20, 25 minutes. We'll give everyone a chance to try the exercises. Okay.
Sounds good.